In this video, we're going to solve for the volume and for the surface area of a prism with parallelogram bases. So we see the bases here. The base, this is one parallelogram here. And then on the back side, we have the other parallelogram. And these are going to be congruent geometric figures. Our bases are congruent, and that's important in helping us solve here. So the formula for our volume of a prism is the area of the base, because the base will change. Sometimes you'll have a triangular prism, other times you'll have a square prism, or you might have a cylinder, which is just a circular prism. So the volume is the area of that base as that geometric figure changes times the height. So our area is a parallelogram, and we know that the area of a parallelogram is just going to be the base times the height. So we need to figure out, well, what is the base and what is the height? So we have, if we look back here in this blue figure, we can see the length of the base. We see that from here to here is a length of 9, from here to here is a length of 5. So if we add those together, we get that the base is equal to 14, and we just need to solve for the height. And the height is going to be this perpendicular line here with the base. And the nice thing about that is this creates a right triangle where we have one of the legs here is 5, and we actually also know this length, which would be the hypotenuse. If we look at the other parallelogram, we see that the side lengths are 13, and we know about a parallelogram that the opposite sides are both parallel and congruent. So that means this length here is 13, and we can solve for this. This is just going to be, if we pull this triangle out, it would look something like this, where I have the hypotenuse is 13 and this base leg is 5, and we can use the Pythagorean Theorem here to say 5 squared plus the height, which would be this piece right here, this orange piece, the height, plus the height squared is going to be equal to my hypotenuse squared. And then it's just solving for there. 25 is 5 squared plus the height is equal to 13 times 13, which is 169. And then if I subtract 25 from both sides, just using inverse operations now to get h by itself, these are going to cancel over here on the left, and I'm left with h is equal, h squared, left off this little squared. H squared is equal to 144. And well, in order to get rid of this squared, the inverse operation of squaring something is to take the square root. And whenever you take the square root, we have to consider both the positive and the negative. Well, that would be h is equal to positive and negative 12. But we're only interested in the positive because we're after a length. So the height is a positive distance of 12, and we can plug that in here, is equal to now 14 times the height of 12. So our area then, 14 times 12 is 168. So this is our area. So we've solved here for the area of the base. And now, this might be a little confusing, but now we're interested in the height. We're not interested, these are two different heights. This height is the height of the parallelogram, but this is the height of the prism itself. And that is this distance here as we look at from base to base. The height is the distance from base to base, which is 16. So we would just plug in these values now. And I have the volume is equal to the area of the base, which is 168, times the height of the prism, which is 16, and when I multiply those together, I get 2,688 as my final answer for the volume. So then if we're solving for the surface area, we want to remember this because this area comes into play with the surface area. So my formula for surface area is 2 times the area of the base, which we said was 168. So we can go ahead and plug that in, 168. And then we want to add to that the perimeter times the height. The perimeter times the height. So, well, the height we already know we said was 16. We just need to solve for the perimeter of the base, which is just saying I need to add one side length, we see down here, one side length plus the second side length plus the third side length plus the fourth, because the perimeter is just a one-dimensional length, the distance around the object. So, well, we know about a parallelogram, like I said, that the opposite sides are both congruent and parallel. So if this one here is 13, then this one is also 13. And we solved up here, we said that this 9 plus the 5 is 14. So this length must be 14, and this one here must also be 14. So we get 2 times 14, or 14 plus 14, plus 2 times 13, or 13 plus 13, to solve for our perimeter, which is just going to be 54. So we can plug in 54 for our perimeter, and then use our proper order of operations. Inside parentheses, we would multiply here, and we can also do our multiplication before we do the adding. That's the last thing we're going to do. So 2 times 168 is going to be 336, plus the 54 times 16 is going to be 648, for a final answer of our surface area of this parallelogram prism is going to be 984.